Hi, it's Gary. Welcome to today's video. One of the comments I received on my video about the weather was why hurricanes, as they're called in the northern hemisphere, and cyclones in the southern, why do they spin in opposite directions? Well, it led me down a research hole that led to the Coriolis Effect, or, as it's more often referred to, it's the Coriolis Force. The scientific definition: it's a force that acts on objects in motion within a frame of reference that rotates with respect to an inertial frame of reference. Quite a mouthful of words. Took me 5 goes to actually get it out properly. And to be honest, when we look at these words, they make no sense, do they? So let's take a closer look to come up with a more understandable description. Let's start with some history. In 1651, the Italian scientist Giovanni Battista Riccoli and his assistant Francesco Maria Grimaldi, they published a paper describing how a cannonball fired to the north would deflect to the east. It's an early description of what would eventually become known as the Coriolis Force. 1674, Claude Francois Millier de Charles, hopefully I pronounced that right, described how the rotation of the Earth affected the trajectory of falling bodies and projectiles fired towards the poles. We'll jump to 1749. Euler, he created the mathematical formula for the acceleration equations that again would eventually become the Coriolis Force. I'm not going to discuss these equations here. The math, I did look at it, it went right over my head. 1778, Pierre-Simon Laplace extended these maths with his tidal equations. Then, 1835, Gaspard Gustave Coriolis, he published a paper where he was discussing the energy yield of machines with rotating parts, mainly the water wheel. And again, we start getting technical, so what I'm going to do is I'm going to come up with some simple examples that we can use to hopefully understand this Coriolis force a bit better. So Coriolis, he described forces relating to angular velocity within a coordinate system and the velocity of an object moving perpendicular to the system's axis of rotation. Another massive sentence, isn't it? He called this the compound centrifugal force, and that's what later became known as the Coriolis force. In the early 20th century, the Coriolis force that started being discussed with respect to meteorology, so the weather. Now that we know the history, well, what is the Coriolis force and the effect? How can we understand it without all this scientific gobbledygook that we've had so far? The best description I found came from the National Geographic website, and what I'm going to do is summarise it here. I'm going to twist it a little bit to really fit the things that I like. So what I want you to do, I want you to imagine Superman. Yeah, that's where I'm introducing things I enjoy. Imagine Superman and he's standing on the equator. He now throws a ball in a straight line to Batman. And Batman, he's standing in North America. But every time he throws the ball, it lands on Batman's right. Now Superman, he flies to the North Pole. And again, he throws a ball to Batman, who's in the same place in North America. Every time he throws the ball, it still lands to the right of Batman. And it's all down to the Coriolis force, and it comes from the rotation of the Earth. Because the Earth is a sphere, it's wider at the equator than it is at the poles. As the Earth rotates, a point on the equator is spinning at 1600 kilometers per hour. At the poles, the Earth is spinning at 0.0005 kilometers per hour. So when he's at the equator, Superman, he's rotating faster than Batman, who's in North America. When he throws the ball, the Coriolis effect, it deflects it to Batman's right. Similarly, when Superman is at the North Pole, he's now rotating slower than Batman, so the ball is deflected to Batman's right again. If you were to repeat this experiment in the southern hemisphere rather than the northern, the ball, it would be deflected to the left. So what's all this got to do with the direction hurricanes and cyclones spin? We'll look at the northern hemisphere first. Air, it tends to flow from areas of high pressure to areas of low pressure, so that the hurricane, it pulls air towards the eye of the storm, which is the low pressure area. As it does this, the air from the high pressure area passes the low pressure area to the right. This is due to the Coriolis force, the Coriolis Effect, that's deflecting the moving air. The result of this, the hurricane, it rotates counterclockwise. If we look at the southern hemisphere, the Coriolis force, it deflects the air to the left, and this results in the cyclone spinning clockwise. The Coriolis force, it's strongest near the equator, but it's zero at the poles. And there's two main results from this. The first, hurricanes or cyclones, they aren't able to form in the equatorial regions, and as such, they're not able to cross the equator. And the other, it's to do with airflow in the atmosphere. Warm air rises from the equator and it travels towards the poles. The Coriolis force, it acts on this travelling air and deflects it. In the northern hemisphere, towards the right or east. In the southern hemisphere, towards the left or west. This is what gives us the trade winds or the easterlies and the westerlies. And pilots, they need to take this into account when they're calculating their routes. So far, we've been concentrating on the effect on air, but water is also affected. Although it does require large bodies of water, and it's mainly observed within the oceans. Now, there is a common myth. Spinning water as it goes down the drain is affected by the Coriolis effect, and that's what determines the direction it spins in. This, it actually isn't true. The Coriolis force, it needs large distances to have a measurable effect. In a sink, it's got virtually no impact. The thing that determines the direction in the sink or your toilet will drain, that's down to the design that the manufacturer used. So hopefully I've been able to answer the question about why weather systems in the northern and southern hemispheres spin in opposite directions. I hope you've enjoyed today's video. Have you got any questions you'd like me to answer? Please drop them in the comments down below. I'd love to add them to my list of upcoming things for me to research and create videos on. Please hit the thumbs up button. Every time you like, every time you comment, just helps with the YouTube algorithm. If you haven't already, please subscribe to my channel so that you can get new videos as I release them. I'll talk to you again soon.